And spermidine in this paper, which I think dates to 2000, inhibited at that time 5 of these hallmarks. So they include things like stem cell dysfunction, mitochondrial dysfunction, telomere attrition, impaired protein folding inside the cell, impaired communication inside the cell, and protection from epigenetic changes. So if we look at that initial paper that they did, at that point in time, rapamycin inhibited 6 of the 9 hallmarks. At that time, we had 9 hallmarks, and spermidine inhibited 5. Since that time, it's been shown by a group in Germany, Hanover, Germany again, that spermidine helps protect telomeres from getting shorter. And 3 additional hallmarks have been added. They are inflammation, gut dysbiosis, and impaired autophagy. Now, spermidine inhibits all 3 of those, plus the other 6. That's 9 of the 12 hallmarks that we can definitively say spermidine stops those pathways of aging in their tracks.
Hello, Leslie. You are the founder and CEO of Oxford Healthspan. So welcome to Modern Healthspan, and thank you so much for joining us today.
I'm really excited to be here, especially because of our Hong Kong connection.
Thank you. Yeah, it's really amazing that we kind of overlapped in Hong Kong before. So you're an expert. You have actually spent some time looking at various areas of Healthspan and health. But spermidine is one of your specialities. So can you give us some history as to what led you into looking at spermidine?
Well, first and foremost, my journey into longevity and healthspan started with my own prognosis of you have 5 years left to live from my doctor. This was in 2004. I was 39 years old. That's the same age that my father died at. And I was diagnosed with rheumatoid arthritis and lupus. At the exact same time, I was trying to have a baby. It was my 5th IVF cycle. I was using donor eggs. You might appreciate that somebody like me, who's half Taiwanese, half American, is not going to easily find a donor. And so I was very focused on, having a baby when I was told that's a bad idea. Your body can't support new life. As a matter of fact, your body can't support your own life. You need to start taking these immune suppressants because your immune system is like friendly fire, tearing your tissues, joints, everything apart. And that was the real beginning of my journey towards looking for things that would frankly make me better. The immune suppressants were very unpleasant for me to take. They didn't feel good going in. They left terrible bruises. And philosophically, they didn't make sense to me. Both of my grandparents went to medical school in Japan, and I had always been told that the body needs to be brought back to balance, whereas my Western doctors were telling me my body the immune system needed to be suppressed. And that philosophical contrast really, I just thought, I think I need to believe in my body's innate wisdom to heal, because when we're young and we scrape a knee, we don't rush to the hospital, right? We know the body will repair itself. So is there a way to tap into that as we try to heal from a serious chronic disease like lupus or rheumatoid arthritis? And I did find that at the time it was a new therapy out of Germany, and it had been used in 13 lupus patients to improve their situation. And in my case, it actually put me in complete remission. That was something called intravenous immunoglobulin. So all of a sudden, I go from someone who wants to have a baby to somebody who knows an awful lot about immunology. Fast forward a number of years, and I find myself back in Oxford. And a number of people know about my history with rheumatoid arthritis and lupus, and they mentioned to me the work that is being done at the Kennedy Institute for Rheumatology by immunology professor Katja Simon and Dr. Ghada Al-Saleh, a researcher in her lab. And I went to see what they were doing, and they were working on this compound called spermidine. And it was reducing all the things that had been, all the biomarkers that had been elevated in my own body when I had my diagnosis. So cytokines, these are all inflammatory markers the immune system puts out. So cytokines, tumor necrosis factor alpha, and spermidine was inhibiting all of those things. And it is known to be highly anti-inflammatory. So when I heard about their work, I said, this is great. Look what you're doing with the immune system of these. They were working on elderly mice and resetting, and actually they would use the word rejuvenating the immune systems of these elderly mice, basically mice that are our age, you know. And I'm sorry about that, Richard, but you and I are about the same age. And I think we would be considered elderly. And I thought, this is fantastic. And I had a guy from Oxford Science Enterprises sitting next to me. And I said, hey, we need to bring this to market. Let's change the name. Spermidine is never going to get out there, but let's tell people about this. And I need your backing. Are you going to invest in this? And he said, oh, no, we won't do that, because this is a food. This isn't food, and there's no patent. And I just was so enraged by that. It was like dropping a match in kerosene. And I think that just set me off. And I thought, I need to get this out to people because this has benefit. And in the United States, I really wanted to get it to my mother, but I couldn't find any food-derived spermidine on the market. So we were the first into the United States with our food-derived spermidine, which we get from Japan. And needless to say, I did get it to my mom.
Just a thought. So lupus and arthritis don't sound like fatal. Why did they say 5 years left? I mean, that doesn't.
So rheumatoid arthritis is not fatal, no, but in 2004, lupus had very poor prognosis. And my doctor, I think she wouldn't have actually, I don't think she would have been so stark, except that when she told me, well, here are the drugs for rheumatoid arthritis, and unfortunately, lupus, there's nothing we have to manage it, and you should just expect it to get worse. And I was so upset by that, because I said, no, I'm in the middle of an IVF cycle. I have to do embryo transfer. You can't do this. This is really inconvenient. You're the expert. I'm the paying client. Yeah. I'm paying you to fix this. So come up with a better answer. And so I think I think I really pushed her to the wall. And I think some patients will do this, will think, oh, if I just pay the doctor, they will fix me and it will be fine, right? And she just kind of stared at me and said, don't do the IVF. Even if you're successful, you have a good 5 years left. And that was her way of saying, I'm really serious. When I say there's nothing you can do, and I had asked her about diet, sleep, movement, meditation, anything. She had said, look, there's nothing you can do. And I do think that is what doctors at that time were told, that there was nothing you could do. And in fact, it was only through my own research that I was able to find a letter to the editor from a group of doctors in Hanover, Germany, who had taken this transfusion of antibodies from thousands of donors called intravenous immunoglobulin and had given it to 13 German lupus patients. and found that they could improve symptoms. And that is what really was the game changer for me personally, was doing the 2 transfusions of IVIG. And that seemed to arrest my immune system from going, from doing all the friendly fire. And it appeared to restore it or reset it. And then I removed all the triggers in my diet that were actually overactivating it. I just took a food allergy test, and I found, oh, all the things I eat every single day, cheese, bread, pasta, all of these things, and eggs, dairy, gluten, eggs, were all things that were triggering a response, a very high immune response in me. So restore the immune system to balance, remove the triggers, and see if the body doesn't reward you with good health. And that strategy worked. So when I then came across Professor Simon and Dr. Al-Saleh's work, I was thinking, gee, this looks like it might have potential to act in the same way that IVIG did. And let's explore this more. Let's see what it's actually doing with the immune systems of these older animals. And why is this happening? It was happening because it was activating a cell renewal process called autophagy. That's Greek for self-eating. And it just is the way. It's like having a little Marie Kondo and all your cells constantly bagging up trash, looking for things that can be recycled into new cells. And when we're young, that process works wonderfully. Also, when we're young, we happen to have plentiful production of spermidine in our cells and in our gut. But as we get older, that tissue production of spermidine goes down, and sometimes our gut production can be compromised by broad spectrum antibiotics, which wipe out the colonies of healthy bacteria that make spermidine for us. So then we're really reliant on getting spermidine from our diets. And some countries are better at this than others. It will probably be no surprise to you sitting there in Hong Kong that the Japanese have plentiful amounts of spermidine in their diet, and they also have the best longevity. I guess it depends if you want to take a country with a population over 100 million or a smaller country like Singapore, which one has better longevity. But for a large population, Japan has the best health span of any country in the world. And I would argue that it's partly because of the high amounts of spermidine they take into their diet. They're constantly microdosing with spermidine every time they eat natto, which I guess maybe you've seen yourself. It's a fermented soy dish. It's like spider webs. When you pick it up with your chopsticks, you've got spider webs going off of it. It's got a very pungent smell. Westerners smell it and they go, oh, that's awful. But it's the same way Asians smell Stilton cheese and go, oh, that's terrible. So it's a delicacy in Japan. And that has the highest food, that's the highest food source of spermidine. And they eat it a lot, but they also eat lots of vegetables. And vegetables are full of spermidine. Any plant material, fruit or vegetable, will have some amount of spermidine in it. And we have to be honest, you're a Brit. In the West, we simply, especially the United States and the United Kingdom, we do not eat very much in the way of, say, fruit and veg. I've heard that here we have your 5 a day, and that in France they say have your 11 a day of veg.
Yeah. Yes. So now spermidine is in wheat, right? Actually, wheat is one of the good sources.
Yes.
But does most of it get removed from like bread?
So it is. All spermidine it's always found in the endosperm of any seed. And it's just like in human semen, it is in the sperm. It is really for the survival of the next generation, whether that is a sheaf of wheat or that is a human baby. It is absolutely essential for cell division and growth and function. And that's why it is in wheat germ. Now, bakers dislike having wheat germ in their bread because it has about 50% of its weight is in omega-6 fatty acids. And that oil goes rancid when it is exposed to oxygen. It goes rancid very quickly. So if you're a baker, you don't want your stock to go off after one day. You want it to stay at least 2 days. And you therefore ask the flour miller to remove the wheat germ. And that is our modern diet, right? We only do that because of the fact that we need to have shelf-stable bread. We don't go to the baker anymore to get our bread fresh, but instead we get it from a supermarket where the loaf has probably been there for a week, right? So it is completely removed from what I'll say, loaves of bread exposed to the modern baking process.
Happy New Year. How are your New Year's resolutions coming along? If you're like us at Modern Healthspan, you're probably prioritizing your well-being this year. And we know that good sleep is absolutely essential for feeling our best. And if I had to pick just one thing to boost my sleep and overall health, it would be magnesium. And not just any magnesium. Specifically, I'm talking about Magnesium Breakthrough by BiOptimizers. Magnesium Breakthrough is formulated with 7 different forms of magnesium, each with its own unique benefits. From improving sleep quality and boosting brain function to supporting a healthy metabolism and managing stress, magnesium plays a role in over 600 biochemical reactions in the body. Even if your New Year's resolutions aren't specifically health focused, it's tough to achieve any goal without good sleep and effective stress management. So why not give yourself a helping hand? Go to bioptimizers.com/modern and use the promo code MODERN10 to receive 10% off your order. Plus, when you subscribe, you'll unlock exclusive discounts, free gifts, and ensure you have a convenient monthly supply. Wishing you a well-rested and successful 2025. And I guess, and also for people like you who are gluten intolerant, then
Yes.
that's also finding sources without gluten is going to be a bit tricky.
So that was an interesting, that's a very good observation, Richard. It was provoked some thought on my part because I've been gluten-free since 2004. And I suddenly realized, am I missing out on an important source of this health promoting compound? Because I don't have any wheat. And wheat is very interesting because it has all 3 polyamines. Spermidine is what is known as a polyamine. And wheat has all 3 polyamines involved in something called the polyamine recycling loop. In other words, if you have all 3 of these, having it once is like having it 3 times because your body can recycle it and keep using it. And wheat has really beautiful proportions of spermidine, spermine, which is good for DNA methylation, and another lovely named molecule called putrescine. And putrescine is the precursor to both spermidine and spermine.
Yes. Yeah, the naming is a little bit unfortunate. I think like the putrescine is because it smells like...
It does smell. It's putrid. Yes. And that smell, that when something goes off, that bad smell is putrescine. And I know here at Oxford, I've got some friends in the chemistry department, and if somebody new comes to the lab and they want to play a joke, they'll take a tiny vial of synthetic spermidine, like in liquid, and they'll open it and just put it in that person's drawer because it will smell to high heaven and the person will have no idea where the smell is coming from.
Excellent. Yes, luckily in computer science, we didn't have that. Okay. So, so we get some spermidine from our diet. but the microbiome can also make some. So could you talk a little bit about that? I mean, do we know which bugs make it?
Yes, there are multiple strains that make it. Some fusobacteria, some Bacteroides can make it. And what you want to do is get fiber into your diet that you yourself cannot digest, but which the bugs in your gut biome love to ferment, and that's what they live on. So we are not just, it's not just us that we're feeding every time we put a morsel of food in our mouth, but it's also our microbiota. And you've probably heard that we have the gut microbiome has way more genetic diversity than we ourselves as humans do. Some people have even said, actually, we've got another living organism inside of us, but we have a very symbiotic relationship with these actually very ancient microbiota because we inherited from our mothers every time we go through the birth canal. A little bit of her microbiota goes into us, and that is the seed colony. And it goes all the way to this direct maternal line. This microbiota has come from mother to child throughout the centuries. And it makes things like serotonin. You've probably heard that 90% of all of our serotonin, one of our happiness hormones, are made in our gut biome. You can make all sorts of other things, like you could make melatonin, you could make B vitamins in the gut. And so it's a little pharmaceutical factory, happy pharmaceutical factory in our gut, but we have to remember to give it the raw materials it needs to function. So it always knows how to operate. And the lining of the gut is, it's like shag carpet. You may remember from your high school biology. And it's got these little fingers, the villi. And deep down in the crypts of the villi, the ancient bugs, they will hide, even if we have broad spectrum antibiotics. Hopefully we don't have too many, so it's completely wiped out. But they do try to hide there, so that if we start feeding them again, those colonies can still grow. And when they grow, they can do good things for us. So it's important to get actual plants in your body. You can't just have fast food and a bunch of supplements. That's not enough because you're not feeding your gut microbiome then. So spermidine is one of the compounds that the microbiome can make, but it makes many other things. So always remember to feed your microbiome.
Right. Interesting. Yeah. So you give it fiber, basically soluble fiber. So just like butyrate, spermidine comes out of the fermentation of
So
fiber.
you can use, a fructooligosacchariide is one of the preferred food types of these bacteria that make spermidine. And it's very interesting if you look at the composition of human breast milk, that there are all these fructooligosaccharides in there. And I remember when I did my microbiome course at, it was CU Boulder and UC San Diego, that I couldn't understand why the baby would be getting all of this fiber that it couldn't digest. But that fructooligosaccharides, those FOSs are meant for the nascent microbiome in the baby that the mother has just given to her baby. So now through breast milk, she's actually feeding both the baby with high fat and a lot of spermidine in breast milk too, but also with the fructooligosaccharides to get the microbiome up and running so it can produce more spermidine for the baby too.
Excellent. Okay, so we have spermidine, we get it through the diet or through the gut, and it has, so we talked about autophagy. So what are some of the other benefits that we get from spermidine?
Let's start with autophagy and maybe the other hallmarks of aging. And Professor Linda Partridge at University College London, Matthias Fuente Alba, one of her colleagues, and Professor Brian Kennedy, whom you may know from his work at National University of Singapore with Andrea Meyer. I saw you interviewed her. They did a paper in Nature where they were looking at the pharmacological targets for slowing aging. And they took all sorts of compounds, including things like estradiol, rapamycin, metformin, lithium, and they ranked them by how many of the hallmarks of aging they inhibited. And spermidine, in this paper, which I think dates to 2000, inhibited at that time 5 of these hallmarks. So they include things like stem cell dysfunction, mitochondrial dysfunction, telomere attrition, impaired protein folding inside the cell, impaired communication inside the cell, and protection from epigenetic changes. So if we look at that initial paper that they did, at that point in time, rapamycin inhibited 6 of the 9 hallmarks. At that time, we had 9 hallmarks, and spermidine inhibited 5. Since that time, it's been shown by a group in Germany, Hanover, Germany again, that spermidine helps protect telomeres from getting shorter. And 3 additional hallmarks have been added. They are inflammation, gut dysbiosis, and impaired autophagy. If spermidine inhibits all 3 of those, plus the other 6, that's 9 of the 12 hallmarks that we can definitively say spermidine stops those pathways of aging in their tracks. And that's quite important. Now, rapamycin is quite the darling of the longevity set, but personally, with my history of having injected a lot of immune suppressants, and rapamycin is the Mac Daddy of all immune suppressing drugs, it's given to transplant patients so that they don't reject their donor organs. That's how strongly suppressing of the immune system they are. I just didn't want to take another immune suppressant like that. But of course, I have to look at the science, just like you. So I looked at the science. I talked to people here at Oxford about it. And I talked to Professor Ghada Al-Saleh, who now runs the UK's only space innovation lab, looking at how we age in space. She's one of the original researchers on spermidine, and has also been, has had students who've looked at rapamycin, and she has said, we can see in fruit flies and in mice that rapamycin has these lifespan extension effects, but it only is in female mice and female fruit flies. We don't know why there is this gender-specific benefit. And the other issue with rapamycin for me is that it activates autophagy by inhibiting mTOR. And mTOR is what we need to grow cells, but also to grow muscle, right? And you and I know, as we get older, one of the pitfalls is that we lose muscle. And we need to maintain muscle so we don't get frail, so that we have enough, we're able to stay mobile and independent. And spermidine activates autophagy by hitting something called the EP300 pathway. It's a totally different pathway, so it allows mTOR to still happen. So you can still have your muscles, but you can get this cell renewal benefit without suppressing mTOR. And so that's really why I was, when I looked at the research, I thought, yeah, this still looks good to me, and why I would prefer it over rapamycin. But obviously, everybody needs to make up their own mind and look at the science themselves. I'm sure you'll have other guests who will be very pro rapamycin. But we don't make rapamycin in our bodies. We do make spermidine. So maybe it's my point of view as a woman, as an Asian woman, that I just would prefer to be as close to nature as possible.
Yeah, that makes sense. I mean, we have had people who are very pro rapamycin, and you can play around with the dosing and the timing, but yes, you are correct. We don't make it. Okay, so we do get the autophagy, and it's interesting that you can get the autophagy and the muscle growth, because yes, that is really important. But it has other benefits.
Yes.
Can you talk about some of the other benefits that it has?
Sure. Perhaps I'll just start again as an autoimmune patient. There's a hypothesis that a lot of autoimmunity starts in the gut. And so gut dysbiosis is one of the new hallmarks of aging, and spermidine helps um, keep dysbiosis down. One of its magic powers is that it actually helps seal up the lining of the gut. And it's possibly one of the reasons why it is found in breast milk, not just for growth, but to prepare the infant gut lining for eventually getting food. Because we know when spermidine hits the lining of the gut, in addition to sealing it up, it also activates the immune receptors that line the gut to keep them to make them have a proper and appropriate immune response. So it sort of wakes them up. And so that's in terms of gut dysbiosis. Inflammation, I've talked about how I was impressed that it actually can reduce TNF alpha, can reduce cytokines. So again, as an autoimmune patient, this was very big, but generally we know that inflammation, this is the work of Claudio Franceschi, the Italian immunologist who coined the term inflammaging. We know that inflammation basically equals wrinkles, right? The more inflammation you have, the older you get. So you want to keep inflammation tamped down. And spermidine does that. As a matter of fact, when sperm are made in the male body, it's a very highly reactive oxygen species event, i.e., highly inflammatory event. And they think that the presence of spermidine there keeps that inflammation down. Even though you've had this big production of sperm, you kind of keep the inflammation down with the presence of spermidine. So that's inflammation. I've talked about autophagy, how it activates autophagy. So those are the three new hallmarks. Of the older hallmarks, stem cell dysfunction, it helps with inhibiting dysfunction of stem cells. It helps with mitochondrial dysfunction. So you may have heard the term mitophagy. That is essentially helping to rejuvenate the mitochondria. Very important throughout the body. Impaired protein folding is another hallmark. So I like to think of proteins as either Lego or let's say, because it's folding and you're in Hong Kong, origami. You've got a piece of paper, you have to fold it exactly the right way to make it into a little origami swan. As we get older, our cells stop making it into a figure that is recognizable. But you need it to be recognizable so that it can create other beneficial compounds in the cell. That protein folding ability can be restored with spermidine. So now we've got 6 of those hallmarks. Another one is protection from epigenetic changes. So we've talked, or you may have talked with some of your other guests about how lifestyle can turn bad genes on and good genes off. Stress will do it, poor sleep will do it. Now, spermidine seems to help put those good genes back on again and silence the bad genes. And I think it's nice if you have spermidine together with spermine, because spermine helps with DNA methylation, again, turning on the good genes, turning off the bad genes. So that's another one. And then impaired intercellular communication. So inside the cell, obviously, different parts need to communicate properly with each other. As the cells get older, they start miscommunicating. And obviously, we want, it's sort of like in a military battle, the guy who's trying to call back to, his commandant, it's got static on the line. So what we're trying to do is reduce that static in the communication between the cells. So those would be the 9 hallmarks of aging that we can see actually are are downregulated by spermidine. And it's very possible that they actually help inhibit the other three. So the other three would be nutrient sensing, DNA protection repair, and cell senescence. Now, why can't I say, I have heard other people say, yes, spermidine inhibits all 12, but we're still waiting to see it in all cell lines. So for instance, the lab here at the University of Oxford, the Simon lab, and the Al-Saleh lab have been able to prove that spermidine rejuvenates senescent immune cells. That's a very big deal. But that's only one part of the body. It would be really great to see if we had definitive proof of it rejuvenating senescent cells in other parts of the body. We know that, for instance, in the heart is one of those organs that does not replace itself hardly at all, to be honest, throughout our lifetime. Even at age 25, only 1% of all cardiomyocytes will replace themselves in a single year. So imagine you need 100 years to replace your heart. And so we need to keep those cells healthy through autophagy. Now, can we actually take senescent heart cells and rejuvenate them? That we don't know. That would be good to know. But we can't yet say that. And so that's why I don't say that it inhibits senescence.
But rejuvenating senescent immune cells would be really important.
It does do that, but I can't say that it does it systemically in the body. And, that part I can say, but I wouldn't want to overstep, right?
Right. So this is kind of at the cellular or functional level. But I do see that kind of you've talked about that it improves skin and particularly hair, right? Hair color.
Yeah.
So that's really interesting because we certainly have interest in kind of being able to get to recolor hair. So can you talk about what you've seen with that?
Yeah. So from the science side, I'll give you the science side and then I'll give you the anecdotal side. So let's start with the science side. Hair follicles I'll collapse it from the 5 scientific stages of their life cycle into 3. Basically, the growth phase, the resting phase, and the shedding phase. Now, as we get older, our hair spends less time in the growth phase than it did when we were younger. That's why some women complain that their hair doesn't grow past their shoulders, or why they say they need to get hair extensions, or their hair isn't thick anymore as it used to be, because our follicles don't spend that much time in the growth phase. Now, pigment production or melanogenesis only happens during the growth phase of the hair life cycle. So if our hair follicles are spending less time in the growth phase and more in the resting or shedding phase, guess what? We're making less pigment. You get more clear or white hairs. And also the texture of the hair begins to change as well. It becomes drier. And a lot of women, once they get past, say, 70, 75, 80, sometimes their hair won't even accept hair dye anymore. That's how much the texture changes. So if we think about what our hair was like when we were children, it's that very fine hair. But then think right after puberty, girls, they have this long, glossy hair that looks, it's a social signifier for fertility. Well, if you take more spermidine, which has also been shown to help with fertility in both men and women, you will also find that the hair follicles will move from the shedding phase into the growth phase after just 6 days exposure. We can see in the lab in older hair follicles taken from facelift patients, we can see that about 25% of the follicles that are in the shedding phase will move back into the growth phase again. So 1, that gets longer. 2, the texture changes. And 3, you're more likely to get pigment. So there are all of those benefits. Now, there are a lot of other things that need to be in place in order for pigment to be there. Yes, you need to be in the anagen phase or the growth phase of the hair life cycle, but you also need to make sure the body has the other nutrients it needs to make pigment. And one of the biggest deficiencies I see globally is iron deficiency, tends to hit women much more frequently than men because women of reproductive age have a monthly bleed and they're losing about half of what they lose. Professor Christian Breiman, who was just speaking with me at a panel at Swiss Longevity Day last week, was saying that half of that, of the blood they lose is iron, which is a lot. And you need iron for pigment. Vitamin D is also needed for pigment. B vitamins are also needed for pigment, B5, B6, B9, B12. And then, you also want to look at copper and zinc, that ratio. Copper is also very helpful with pigmenting hair. And a really big one is thyroid hormone. Now, with spermidine, one of the things we can see in the lab studies in Japan are that spermidine increases something called L-tyrosine. And L-tyrosine helps, together with iodine, helps the body make the thyroid hormones T3 and T4. And I'm a hypothyroid patient, so I might talk to a little bit quickly about this, but T3 is the bioavailable thyroid hormone that our body makes, but we've got to convert it from T4 into T3. And the molecule that does that is selenium. And at least here in the UK, and I've heard from doctors in Australia, there is no selenium in the soil in the UK or in Australia. So if you want to get that into your diet, you're going to have to supplement by taking, say, 3 Brazil nuts a day. And so if you can get the T3 you need, your thyroid needs, you've got all those other vitamins and minerals, and you do not have underlying untreated chronic infections like H. pylori or Candida, then you have a good chance of reversing your gray hair. Now, to the anecdotes, I have seen people who have reversed their gray hair. Some just with spermidine, others with a combination, some without spermidine. So it's not a one-size-fits-all thing. It is a very unique process to you. And your biology is different from my biology. I might just need more B5 or spermidine, and you might need to simply get your thyroid optimized, right? So what I have seen with spermidine is that in a 79-year-old individual who was on spermidine, our food-derived spermidine, for 5 months, she began to get pigment back in her hair, and it started at the roots and then went up. And it was very strange. It almost looked like she had a windy band on, one of those hair bands, because her hair here was white and then here was dark. And it was not at all what she was expecting. And when she reported it to us, I wrote back, "Congratulations, your hair color is coming back." But this was a British individual who wrote back and said, "I don't want my friends to think I'm vain and I'm coloring my hair." Now, if this had been somebody in California, they would have been thrilled. But, go figure, the Brits want to look their age. So anyway, that's one instance. We've had other people like Dr. Stephanie Estima, Nadine Artemis. They've all said they've seen gray hairs that have repigmented again. We've had both genders. We've had people report they have less gray hair. Does it remove all gray hair? In the case of that 79-year-old, it seems to have. That seems to have been her main problem. With other individuals, it really does vary. So there was an influencer in Spain who posted on Instagram that, it was the only supplement she took over a 3-month trip in India. And when she came back, her hairdresser said, "I don't know why, but you've got all these new hairs and you have less gray hair." So those are some of the anecdotes. People do seem to notice faster hair growth, the need to cut their hair more frequently. They also notice the need to cut their nails more frequently. They do also notice more skin firmness. And I think that if you consider all three of these, hair, skin, and nails, these are fast growth cells, right? They turn over very quickly. And that's why we're constantly cutting our nails. That's why women use exfoliants. They want to slough off, the top layer of cells. And that's why we're cutting our hair. These are the fast growing parts of the body. And what I will also say is that because they are sort of superfluous to the survival of the organism, they are the first to suffer. When the body needs spermidine, say, to keep autophagy or mitophagy going in the heart or the brain or the bones, it's going to take it from the hair follicles. Hair follicles are not essential to survival, but the heart, the bones, the liver, all of these places are. So the body makes that wise decision to allocate the spermidine to those vital organs so the organism survives as optimally as it possibly can. Who cares about the hair, right? But once we top up, and we top up with those other missing nutrients in our store cupboards, let's say the body is a store cupboard, just like you have a kitchen store cupboard, you top those things up, the body can suddenly do things again. It still remembers how to make these things. It just doesn't have the raw materials. So once we restore raw materials, things work again.
One more kind of macro level thing that I would like to talk about is hormone health. So spermidine and hormone health, I guess both male and female.
So we have to separate the preclinical from the clinical trials. So for people who don't know, preclinical are animal studies or cell, petri dish studies. Clinical studies are those that are in humans, and they are really the most important. And so there has been only one study I am aware of that has been done on humans with food-derived spermidine. And this was done in Canada. They were using 5 milligrams of spermidine, just so people know. And in this case, over the course of 30 days, spermidine and spermine supplementation, because they were also using wheat germ-derived spermidine, it reduced salivary cortisol levels in both men and women by 58%. Now, when you reduce cortisol, which is a stress hormone, you are preserving progesterone. And progesterone is vital for women because it obviously acts as a balancer of estrogen, but it's also a very calming, soothing compound in both men and women. And because cortisol is made from progesterone, if we reduce cortisol, we are sparing progesterone. In addition, in this study, they could show that it normalized hormones and increased DHEA, which is a precursor to all the reproductive hormones, testosterone, estradiol, and progesterone. And it also increased pregnenolone, another precursor of those hormones, as well as increasing testosterone, progesterone, and estradiol as well. So all of those 5 markers went up: pregnenolone, DHEA, testosterone, estradiol, and progesterone. And in men under the age of 50, testosterone increased an average of 49%. It also said that this particular study, which was done by Bandera and Wilson, in case people want to look it up, the authors also said that both fertility and sexual performance, for those, you needed to reduce cortisol levels, and spermidine and spermine do that together. Of course, as with all science, we need larger trials, but this is a food-derived molecule. There is no patent, That's what I said at the beginning of this interview. There's no patent, so there's no incentive to get a large-scale trial together because those studies can cost $1 million or more. And so that's kind of the problem. On the other hand, if we look at the long-lived healthy populations around the world, and again, the blue zones, and I know there's been controversy. Actually, it was brought here at the University of Oxford where some of those data were questioned. But if we still, those are pretty long-lived populations, and Japan is still a healthy population. If we look at their diet, it is very high amounts of naturally occurring food-derived spermidine as well as spermine. And this appears, at least from an epidemiological point of view, to confer some health span benefits. There are several studies, maybe 3, that talk about this very thing.
Yes. Okay. So we talked about getting your spermidine from your food, which is always like option 1. But especially we get older, our gut becomes maybe less capable of absorbing, and we also like our internal manufacture of spermidine goes down. So if we want to supplement with spermidine, what kind of dose would you recommend? And does the format matter? How bioavailable is it?
Format does matter. And there is a difference between food-derived and synthetic. So I don't know if you had this powdered orange drink that went up with the astronauts called Tang when you were growing up. But when I grew up in the United States, Tang was what all the astronauts were drinking in space. It was basically orange-colored sugar water and had some vitamin C. And people said, that's better than an orange. Well, that was synthetic. And I think we can all now agree that an orange, a food, is going to be better than the synthetic. We know that to be true of bioidentical hormones versus the old HRT as well. So when you're looking for supplementing, look for a food-derived spermidine because it's more bioavailable than a synthetic. And you would also want to look, hopefully, for one that has the 3 polyamines involved in the polyamine recycling loop. So that's spermidine, spermine, and putrescine. If you can't find all 3, try at least to get the putrescine because it's a precursor to spermidine and spermine both. So at least you have that precursor to possibly get that loop going in you. In terms of foods that you could eat, well, you can, different societies have different high spermidine foods that they favor. So in Japan, it's natto. In the United Kingdom, it might be cheddar cheese. And I always try to promote the cheesemakers of the Cheddar Valley post-Brexit, but cheddar has a lot of spermidine in it. Assuming your doctor is not afraid of the, of the fats in the cheddar cheese, that does give you some. So cheeses that are long fermented, Parmesan is another one, Gouda is another one, and you would want to get some of that in your diet. Fermented sauerkrauts will have some spermidine in them. Mushrooms, peas, legumes. I know some people say, oh, I can't eat beans. But actually beans are a source of high spermidine. So if you can find a way to tolerate them, maybe switching to a different type of legume, those would be very helpful. But always look for the food-derived spermidine, always, whether it's in your food or it's in your supplement. And in a supplement, if you can also find something that helps promote the gut biome production of spermidine, like a fructooligosaccharides, that would be helpful too. And so, for instance, when I was formulating Primidine, which is the spermidine that I make, I was really looking at human breast milk and thinking, all right, so breast milk is the most perfect food. It is nature's elixir, and we know some sick people take it. We know bodybuilders take it. How do I make a supplement that is as close as possible to, say, human breast milk? And we took the spermidine, spermine, and putrescine from the wheat germ, but then we added in a fructooligosacchαρide, a resistant starch. Was from maltodextrin, was from beets, but maltodextrin is actually a fructooligosacchαρide. And if it has more than 70% fiber, it's a resistant starch. And that is actually beneficial to the gut biome. So that was that formulation. That's why we formulated it like that. Because not everybody can handle fructooligosaccharides, people who find discomfort or bloating after they eat fruit or vegetables probably have a little bit of SIBO, small intestinal bacterial overgrowth going on. They can't take those things. And of course, autoimmune patients always try to avoid gluten. For those individuals, I went to Okinawa in southern Japan, very close to Taiwan, and I found out of 120 different strains of chlorella, I found one that uniquely had the highest amount of spermidine, and crucially gave me the 1 milligram of spermidine that has been shown to be the minimum effective dose in humans. So you asked me earlier about minimum effective dose. I told you about that Bandera and Wilson study and hormones where they used 5 milligrams, but in fact, in another clinical trial, so with humans, not a petri dish, not animals, it was shown that 90 days of 1 milligram of supplementation of food-derived spermidine improved cognition and memory in those with subjective cognitive decline. And that has been followed up with another study where they used a slightly higher dose of 3 milligrams, but in actual Alzheimer's patients. So, if you're not an Alzheimer's patient, then 1 milligram appears to be the minimum effective dose. And the chlorella really helped get that down into two tablets that were gluten-free for all the other autoimmune patients out there who couldn't take the gluten.
Yes, it's good to be gluten-free. There was a study, actually, there was a study from Lübeck University, you may be familiar with, where they looked at high dose, but I think it was 6 milligrams, but anyway, it was a higher dose of spermidine. And the one line thing is that it didn't raise the spermidine in the body. Are you familiar with that? And
I'm familiar with the study.
Yeah.
And we've talked about it here with Katja Simon and Gada Alsaleh. All the subjects were under the age of 30. And so they already would have had reasonably high spermidine levels because their tissues are still making it and their gut biome is still making it. Like most universities, when you need subjects, you go to your students, right? And that is exactly what the Lübeck study did. They used their students. So I know nobody was over 30. They might have even been younger. So in that case, what does the body do? You give it extra. And the body says, well, I don't need this. My store cupboards are full of spermidine. It's just like in your kitchen. Oh, the cupboards are full. I don't need more. What do I do with this extra? Well, we'll get rid of it, right? And so that's essentially what Gada and Katja have said, is that you have enough, you don't need more. Maybe you can convert it into something else, right? You've got spermidine is made from L-ornithine and L-arginine. Who knows? Maybe those levels went up. But if it were in an older cohort of individuals, then we would have seen an increase. And Gada and Katja have certainly seen it themselves in older individuals. So for them, it was really about the study design that they didn't like.
Right. Yeah, I did look at the study. I think the median age for male and female were like 24 and 26. So
Yeah, they
yeah,
were young, right?
they
They
were
were
young.
students. This is how a lot of these studies are done at universities. Yeah.
Yeah.
I will say there is another study that people bring up, and I can't remember where it was, but I would like to address it because I think no discussion of spermidine is complete without obviously looking at what are the downsides, right? And actually, so there are two things. One was a study around high spermidine levels and stroke. So this study said if you have, in stroke patients, it appeared that they had very high spermidine levels. And again, asking the experts, Katja Simon and Dr. Gada Al-Saleh, they immediately said, but this is what the body does when the heart has an event. It is trying to raise spermidine to activate autophagy in the heart. This is their explanation. It is not a proven thing. It is a hypothesis. But where we also see it is in bone. Women who have osteoporosis also have high spermidine levels. Is that cause or effect? And they would say that actually, because there is greater need to fix the bones, and it is something that spermidine helps with, there is higher presence of spermidine there. Just like in the heart, cardiomyocytes, they need autophagy. That's why there is that high presence. Another thing that people might wonder about is with regard to cancer. Now, cancer is it's very interesting because it is an immune modulated disease. And when we are young, there is cancer around the body, but the body is able to identify it and to target it and get rid of it. As we get older, as the immune system ages and is unable to identify it and get rid of it, cancer has a greater chance of getting a foothold. And there is work from Professor Hanjo at Kyoto University. He's the 2018 Nobel Prize winner in medicine for his work identifying proteins involved in cancer. He has said that spermidine is cancer protective, but it is before the immune system fails and cancer has taken hold. So we have seen in some cancers that it's possible that cancer, being very smart, could grab the spermidine and try to use it for growth, but it's nuanced because it does seem to be beneficial to lung cancer patients. So there's a lot more research that needs to be done there, but one of the world's experts on cancer and tumorigenesis, Professor Hanjo, the Nobel laureate at least, says this is potentially cancer protective. So those are the two studies that I think, if you are really doing your due diligence on this molecule and you're thinking, what are the downsides? Those would be the two types of studies you would come across. But I think that's probably it. Otherwise, spermidine appears to be very beneficial and something that all the long-lived populations include in their healthy lifespan diets.
Speaking of aging, so when you're young, you're fine, right? When you're a university student. So at what point would it become possibly helpful to supplement with spermidine?
Again, we're bio-individual. So if I were to try to generalize, I would say that as a woman, before you have a baby, you're probably fine. After you have a baby, you will have just given a lot of spermidine to the baby to grow in utero, and you will be giving lots of spermidine to your baby if you're breastfeeding. If people are breastfeeding for 2 years, which is what I did, then you're giving loads of spermidine to your baby. And you'll probably notice it in thinner hair, maybe more gray hair. So you would want to top up. Another time where you would need it would be after a virus or some kind of a bad infection. And that's because spermidine activates a cellular process called BiOptimizers. So it's almost like spermidine produces all of these garbage bags. And with virophagy, you bag up all of the bad viruses and you get rid of them. With mitophagy, you bag up all the bad mitochondria and get rid of them. Same with stem cells. So it's that's why about 1/3, I think it was 1/3, or maybe it was 1/4 of all COVID patients reported hair loss in the months after they recovered. That's because the body would have been, again, in its innate wisdom, allocating spermidine for virophagy and saying, don't need the hair, superfluous to organism survival. Let's fight this infection. So those are 2 times when you would want to top up. As we get older, as production falls off, I would say in your 40s, you would want to start thinking about it. But it's so bio-individual. If I look at somebody like me who at age 39 had these autoimmune illnesses, I was very clearly experiencing the inflammaging that Claudio Franceschi described. I was older than my 39 chronological years. I was biologically older because my immune system was aged and not working properly. So for somebody like that, you would want to start earlier, right? So it does kind of depend on your biological age.
Right. Yes. Yeah. I mean, that would absolutely make sense. You look at aging in a kind of holistic way. Would you be able to share what your protocol is? Like
Sure.
kind of diet, exercise, sleep. What are the important things for you?
Yes, the foundations, they're boring, but so true, right? You have to optimize sleep, movement. Everybody knows you want to get to bed before, well, hopefully between 10 and 2 a.m. The earlier, the better to activate make sure you get the deep sleep cycle, which is the only time when the lymphatic system is activated. So sleep, make sure it's dark, make sure it's cooler, make sure there's no noise, and reduce blue light exposure. And there's a great, if you just do a YouTube on get red light screen on your iPhone, you can, with just 2 clicks of your iPhone, you can immediately turn it into a red light. It's got a red screen, so you block out all the blue light. That reduces melatonin production and that increases cortisol. So that would be a tip for sleep. On movement, I've got a bit of a gammy knee at the moment, and yeah, I'm double jointed. Went to a personal trainer, did a little too much, locked up my knee. Not good, but I'm still walking. So you want to try to get those 10,000 steps in. But if you don't manage to do it, aim for at least 5 to 6, because that appears to still confer great benefit. Movement is absolutely fundamental to who we are as humans. If you don't like walking, just try dancing in your kitchen. I do it, when I'm cooking, and you get all these extra steps in a fun way. Or go out with your partner for dancing if you can. So movement is second. Obviously, diet is a big one for me because of my immune system. So I am still gluten-free. I am still dairy-free. If I have dairy, it will be something with low casein in it. Casein is a type of protein, so a lot of people know about lactose in dairy, but for me, it's also the casein protein there. So butter is okay, but other things are not for me. With regard to my morning sort of setup, I've got my morning coffee here, and single estate beans, right? Single estate beans from Colombia. I know the farm that they come from because the lady who sells them to me, it's her family farm. We're very lucky here in Oxford like that. And, I add to it collagen. And collagen is great. I recommend it for both men and women because I think if we're living longer, we want to look as good as we possibly can. So it's very helpful for hair, skin, and nails too. I add medium chain triglycerides from coconut creamer into my coffee as well. Very good for brain health. I also add raw cacao. If you listen to Dr. William Lee, he'll say that that helps with stem cell release. I have no idea, but I have been doing it for the last 4 years, only because I'm kind of a chocolate hound and I like that taste in my coffee. Not everybody does. I also add faux tea or hushowo. This is a Chinese herb, and maybe you and your wife are familiar with it. Very famous because of its anti-aging properties. It's essentially Japanese knotweed, which is what everybody in Britain hates seeing in their garden. But I add that, and because of my hypothyroidism and the fact my blood pressure is a little low, I add in a little sea salt. And other people who taste my coffee say that is undrinkable and completely disgusting. But I've been doing it for years now. And I'm used to it. My taste buds have completely changed. It sets me up, though, for a productive day. I feel good. And I do have my thyroid optimized. I do not take levothyroxine or Synthroid. I take a food-derived thyroid hormone, which comes from it's bovine. Actually, this is adrenal is bovine. The thyroid stuff is pig's thyroid. And it's what Hillary Clinton is on. Bernie Sanders is on levothyroxine, the synthetic. Hillary is on the on the same stuff that I'm on. The synthetic doesn't work for everybody. So those are really the big things for me. The rest of the time, I just try to get I eat lots of mushrooms, a lot of broccoli. Frozen spinach is a great thing to have in your freezer. If you've got frozen spinach, you've got frozen sofrito. Sofrito is just a combination of diced onion, celery, and carrots. Have those in your freezer. Then you've always got the base for a soup. I have loads of soups. And if I'm having, say, broccoli, I'll boil it. And then I'll put it, and then you get rid of the oxalates that way, which are thyroid suppressing. I'll put that then drained on a plate. I'll drizzle olive oil on it so the olive oil doesn't get too high heat. And then I'll add some furikake, which is black and white sesame seeds, a little bit of nori or seaweed flakes, maybe some ume shiso flakes. That's then really simple, fast, and healthy. So I've gone food. Social. Living in a university town is fantastic. I get to meet people of all ages and have wonderful colleagues who have sparky ideas. And, I just saw Sir Christopher Ball, one of my co-founders of the Oxford Longevity Project. He's about to turn 90, and he did a park run 2 weeks ago, and he was so proud of this, that he had done park run, which is a 5K run. And, he's aiming for a marathon at 100. And I think this is great, to meet people like that. Or Dennis Noble, who was just in Santiago, Chile at Congreso Futuro and presenting there, but he's 88. So I'm around a lot of role models, but I'm around a lot of young people. And I think as a society, as a community, we need to get everybody together, right? Engaging with one another. And it's an opportunity for me to give back and teach others. But actually, I learned so much from the young generation, from people who are my daughter's age or researchers at the university who are in their 30s and starting out. And That's how villages used to be. Everybody was together. People who are older weren't siloed away in these old age homes, everybody sitting in a wheelchair. We were all together. And that's one of the benefits of living in a university town like Oxford. I can do that.
Do you take any supplements? I mean, obviously, apart from uh,
I do.
spermidine.
I do. And with supplements, again, they're bio-individual. So everybody always asks me, what do you take?
Mm.
I will tell you, but with the caveat that these are uniquely appropriate for me and my biology. Your biology, you need to test for. Please work with your functional medicine practitioner to run your panels for vitamins, minerals, antioxidants, hormones, and underlying chronic conditions so that you can address every single one. So in a day, I will take glutathione, which is the body's master antioxidant. I will take DIM, calcium D-glucarate, and I will take N-acetylcysteine. These four are detoxifiers. Why do I take them? My doctor says that while I am on HRT, I need to detoxify the estradiol that could convert into the carcinogenic type. And I am genetically a poor detoxifier of that particular thing. So I don't want to go off bioidentical hormone replacement therapy because it makes me feel great and I highly recommend it to others. But I am one of these susceptible people. So I take precautions to mitigate against any harm with those four antioxidants. I also take B vitamins. I take adrenal support. I take I'll call it a multivitamin, but this is not Centrum. This is something that is specifically tailored to women who are over 50. It has some adaptogens in it, like rhodiola, ashwagandha. And then I take omega-3 fatty acids. I take an NAD precursor called Nutrido, which is done by another scientist here in the United Kingdom, Nicola Conlon. And I'm trying to think. Oh, and Dr. William Davis. Do you know the book Wheat Belly?
No, I'm not
You don't
familiar.
know it. So Dr. William Davis has done several New York Times bestsellers, one of which was called Wheat Belly. And I recently met him in Las Vegas at the American Academy for Anti-Aging Medicine's annual conference. And he gave me his supplement, which is called Oxyceutics, and it is probiotics. And I've got to say, I feel a difference. And so I thought that was a really good product. There is also a food-derived zinc product called Marine Health Foods out of Ireland that I take. I think we're coming to the end really here because I can't think of anything else that I do. CoQ10. That's basically it. I know a lot of people take 150. I can't. I just can't do it. I add a little creatine and Spermidine powder into a little berry smoothie that I get some frozen blueberries, some almond milk, and I put the creatine and the Spermidine powder in, and it's like dessert. I just can't swallow thousands of pills. It's not in me. I have enough, you know. Um, oh, I forgot to mention before bed, progesterone, melatonin, Spermidine GF, astaxanthin. That's it.
Taking melatonin.
1 milligram and no more. Microdosing can sometimes be more impactful than overdosing. Everybody's unique, though. You have to see what's right for you.
Yes, yes, absolutely. Do you take any protein powder?
Yes, I do. And it's chocolate flavored, of course.
Yes.
But yes, and you can add an egg. Sometimes I add an egg into that little berry ice cream smoothie I make with the Spermidine. You can add protein powder in there. You can add collagen in there, or like I said, an egg, a raw egg, and that just gives you that little extra boost.
Okay. Excellent. So, Leslie, thank you so much. You've been very kind with your time. It's been great chatting with you. So, if people want to follow your work, and also if they want to get the supplement, and we will have a code in the description for 15%, I think. But if they want to get the supplement and they want to follow your work, and also the Oxford Healthspan
Longevity project.
longevity
Yeah.
project. So where can they go for that?
So for the Oxford Longevity Project, a lot is on Instagram. And sorry to those people who are not on Instagram. We're also on LinkedIn, but it's Oxford Longevity Project, all one word. We do have a conference called the Smart Aging Summit. We'll be doing on the 7th of June at Rhodes House. That's the home of the Rhodes Scholars at the University of Oxford. So if you want to come, tickets are now on sale. And this year's topic is mindset. And we'll have Professor Jeremy Howick from the University of Leicester talking about the placebo effect. We're going to have a cancer specialist coming from Egypt talking about mindset and cancer. We've got Dr. Louise Newson, who's a hormone expert. She's going to be talking about mindset, mood, and hormones. Dr. Olivia Lessler, who is John Frieda's and Chris Hemsworth's doctor, she's going to be talking about psychoneuroimmunology. So that's the Longevity Project. Me personally, Leslie's New Prime, Leslie, then S, New Prime. That's on Instagram, also on YouTube. That was kind of a lark doing that channel on YouTube on gray hair reversal, really because my girlfriends they didn't get that I didn't have to dye my hair at my age during COVID. So that's a bit of fun, really, that channel. So you can find more there. And then Oxford Healthspan is also on Instagram, and that's more for Spermidine.
Right. So we will add those links into the description. Okay. Yeah, mindset. I actually kind of wanted to talk about mindset, but maybe next time. Yeah, because it is so important.
Mindset is important. Anybody who wants to learn more, look at the work of Professor Carol Dweck in the psychology department at Stanford University. Staying curious and open-minded is so important as we get older, because we now, you and I, at our age, we have to imagine a new future that is going to look radically different from what age 60 looked like to our parents. And we've got to be open-minded about that in that imagination and creation of this new reality, because we do have a new long life that we've got to live.
Yes. Yeah, it's so important to be looking for new things and not thinking about the past, but thinking about what are the new things that I'm going to do.
Exactly.
And yeah.
Just like what you're doing right now, totally new and different, not what you thought you'd do when you were 20.
That is true. That is very true.
Well, thank you so much for having me today. It's been a real pleasure, and so nice to meet another expat in Hong Kong.
Okay, Leslie, thank you so much. Very much enjoyed this.
Me too.
Thank you.